We have the example about the formula weight. So calculate the weight of water, which is the H2O, no? Okay, solution. Since there are two atoms of hydrogen and one atom for the oxygen, no? In a formula unit of water. So then the formula weight is, so we have H is equals to 2 times 1, that is equals to 2. Then oxygen, that is 1 times 16 is equals to 16, no? So we can now add, so therefore the formula weight of this water, that is equals to 18 or 18 grams per mole. Okay. The next, for mole, chemists are able to count atoms and molecules by relating number to mass. So they have created a counting number called mole, no? Okay. So a mole of 6.02 times 10 to the power 23 particles, such as atoms, no? Molecules or ions. So this number is called Avogadro's number. So in honor of the Italian physicist and chemist Amedeo Avogadro, no? Okay. So in his formula, we have mole that is directly proportional to the mass but inversely molecular weight, no? Okay. So for example, calculating the number of molecules. So calculate the number in 24.5 grams of CO2, no? So we have first calculate the formula weight of CO2 and then use the relationship between molecules and moles to find number of molecules. Okay, so we have the formula weight of CO2. So C is equals to since in there are one atom in the carbon, no? Okay, consists of one atom. So C 1 times 12 is equals to 12. Then for the oxygen, that is 2 times 16, that is equals to 32, no? For the formula weight calculated, which is 44 EMU or 44 grams per mole. Okay. Then we need to find the number of molecules, no? Okay. So we have since the given is 24.5 grams of CO2, then we can now convert. Okay. So take note that in 1 mole, that is equals to 44 grams on this compound, no? Okay. Then we can now convert. Okay. So 24.5 grams of CO2 times the 1 mole of CO2 over the 44 grams of CO2, so that we can now cancel these grams. Okay. Then since we can find the number of molecules, so which is we need to convert, no? 6.02 times 10 to the power 23 molecules. So cancel mole, then we can now obtain the value of 3.35 times 10 to the power 23 molecules of CO2, no? Okay. So again, to finalize the answer, 24.5 grams of CO2 has 3.35 times 10 to the power 23 molecules. Okay. So that is the final answer. So another example is calculating the volume of Avogadro's number. Okay. So calculate the volume in cubic centimeters occupied by 3.5 times 10 to the power 26 atoms of aluminum if the density of which is 2.7, no, grams per cubic centimeter. Okay. So first we need to convert this, no, since we have the given of 3.5 times 10 to the power 26 atoms. So we need to convert into mole, no? So therefore 1 mole of aluminum, yes, that is equals to 6.02 times 10 to the power 23 atoms. Since we have the given, then we cannot convert and cancel atoms. This is not a gal, but is grams. Okay. So this is gram. Okay. 1 mole of aluminum, that is equivalent to 7 grams. Okay, so again, from the given density, which has 2.70 grams per cubic centimeter, so we can now convert, no, and we can cancel these grams, no, then also mole, then mole. By the way, molecules is the same as atoms, okay, or it is another called atoms or molecules, no. Okay, so next, to find the volume, to calculate this, okay, in your calculator, so we can obtain the volume occupied, that is equals to 5.81 times 10 to the power 3 cubic centimeter. Okay, so that is the final answer. So next example is how many moles of iron does 25 grams of Fe represent. So note the atomic weight of iron Fe is 58.8 grams per mole. Okay, so for the given, we have 55.8 grams per mole. So take note, again, 1 mole, that is equals to 55.8 grams. Okay, so since we have the given, and then we convert to moles, no. Okay, so 25 grams times the 1 mole over 55.8 grams, and then it is equals to, we can cancel the unit of grams, that is G, no. Okay, then to obtain the units of mole. Okay, so therefore the answer is 0.44.8 mole, no? So that is the final answer. Next, calculate the weight of muriatic acid. So since in hydrogen, or and this is the chemical compound of HSCl, no? Cl is chlorine. Okay, so there are consist of both one atom. Okay, so therefore 1 times 1. Okay, then Cl is equals to where chlorine, that is equals to contains one atom, then also they have atomic mass. Okay, so we have 35.45, no. Okay, so that is equals to 1, then we have 35.45, and then we can get the total, no. So that is 36.45, okay, AMU. Okay, so that is the final answer. So next, in empirical formula and molecular formulas, so the empirical formula of a compound gives the smallest whole number ratio of atoms that makes up the compound. Okay, so the molecular formula of a compound is the true formula and show the actual of each element present in one molecule of the compound. Okay, so for example, calculate the empirical, then the molecular formulas of glucose, no. A simple sugar, if a certain sample contains 393.4 grams of carbon, no, in another is 66.07 grams of hydrogen and 524.2 grams of oxygen. So the molecular weight is found to be 90, no. Okay, so we get the atomic mass of the carbon, which is 12, then also the hydrogen 1, then the oxygen is 16. Then we have 393.4 grams of carbon times the 1 mole over 12 grams. Okay, so we cannot cancel grams or the unit. Okay, so to obtain the unit of mole, that is equals to 32.78 mole of carbon. The next is we have 66.07 grams of hydrogen times the 1 mole over 1 gram. Also, we can cancel the gram to obtain the value of 66.07 mole of hydrogen. Okay. Another is 524.2 grams of oxygen times the 1 mole over 16 grams, so that is equals to 32.76 mole of oxygen. Then again, we get the smallest value so that we can to obtain the divisor, no? Okay, so we can choose the smallest. Okay, so since the smallest is this, no, 32.76 mole of oxygen, so that we can now divide, no? So here 32.78 divided by the 32.76, so approximately equals to 1. Then we have the hydrogen, the 66.07 over 32.76, approximately equals to 2. Then we have the oxygen, 32.76 over 32.76, that is equals to 1. So therefore the empirical formula, that is equals to CH2O. Okay. So next, to find the molecular formula, so we can now obtain, no, this formula of the empirical. So atomic mass again 12, then hydrogen is 1, then oxygen is 16. Okay, so the molecular formula, so we have C times since in carbon is 1 atom, so times 12, and atomic mass, no, that is equals to 12, then H 2 times 1, that is 2, then oxygen 1 times 16, that is 16. So therefore the total is 30 EMU. Okay, so take note, the molecular weight is to be found 90. Okay, so we get 30 to find the value of our multiplier, you know. So 30x is equals to 90. So since we get this, no, okay, so since in 30 or 90 divided by 30, that is 3, no, we have CH3H6O3. Okay, so that is the final answer. Okay, so this is the final answer. Then in percent composition, so the subscript in the formula of a compound give the mole ratio of atoms of the elements in the compound, refers to the mass ratio of the elements converted to percentage. Okay, so for example, calculate the percentage composition of hydrogen in rubbing alcohol. Okay, solution in isopropyl alcohol CH3H8O. Then again, determine also the or less than the atomic mass of carbon, hydrogen, and oxygen. Okay, so we have 3 mole of carbon. Okay, then times the 12 grams per mole, and that is equals to 36 grams of oxygen. No? Then another is 8 mole of hydrogen, that is equals to 1 gram per 1 mole, that is equals to the 8 gram of the hydrogen. Another is 1 mole of oxygen times the 16 grams per mole, that is equivalent to 16 grams of oxygen. Okay, so to obtain the percent mass of for the hydrogen, so we have this formula, the mass of hydrogen over the total mass times the 100. Okay, so since we have to get total of this composition, no, so we have the hydrogen. Okay, so that is over the total mass, which is 36 plus 8 plus 16 times 100, that is the percent mass of hydrogen. Okay, and that is equivalent to 13.33%. So that is the final answer.